let's wait a couple more minutes since it's the first time. Maybe someone else will try to join. And can you see my screen?
Evet hocam.
So while we're waiting, your username should be first name, last name. For example, Burak, Sezer. You should add your last names. Okay, so today we will start with using Sage and to do what some of the things we discussed until now. Okay.
Hocam, before to start, can I ask something?
Of course.
Are you gonna record this lecture or not?
No, because we should discuss. And if I record, in general, people will not participate.
Okay. Okay.
So if I hope you all have a CoCalc account already. This is when you start a new project. This is what you see. So let's create a file. We can create either a notebook, Jupyter notebook, or a terminal. You see all the options here. You can have a LaTeX document actually. And what we want now is a Sage worksheet. Sage is the software we use. So we have a Sage worksheet. Let's confirm it works. In the beginning, the first command, it takes some time just because it has to initialize stuff. As you see, this is a free trial. It just means it has all functionality, but it is slow and it doesn't have internet access. But computationally, it has, the tools are there. Okay, so 1 + 1 is 2. And this is, as you see here, it's Sage. So the interface of Sage is Python. Not interface, the language. Sorry, is Python. So you can define a function taking some argument, and that's a function in Python. Okay. And it's full Python is usable. Essentially, Sage extends Python with libraries for doing computational stuff. Okay, so one of the things that Sage provides is things for that we discussed and in terms of algebra, right? So, for example, if you say QQ, this is the rational field. So Sage knows, and you can ask, is 4 in there? It is. It is 1/4 in there. It is. It is. Let's see if this works. Did it say true? Why?
I think this is the rational number.
Yes.
And that's why it's in rational number, SQRT.
Of course, every square root actually is a rational number, right? So is a square root of -1 or 2? It's not, right? So except for rationals, we have the real numbers. But you remember we discussed that real numbers actually in the computer cannot be represented exactly. So what it says is that this is a real field, the field of real numbers, with 53 bits of precision. Okay. So we have RR, we have CC, and these are both not exact, but ZZ, the integers, and then the non-negative integers, these are all predefined, and also AA, which is algebraic real field. And for example, SQRT of 2, it is in there. This is the square root, right? Square root of 2 is an algebraic number. It was not a real number, it was not a rational number, but it is an algebraic number, as we discussed. Questions until here? Now, okay, RR has 53 bits of precision, and this often will not be good enough. In that case, we can say I want a real field with 1000 bits of precision. And now, what is R? It's what I asked for, right? And I have this and a real field with 5 bits of precision. And I can cast things. So I can say that A is, let's see if this will work. So if I say 5, this is 5 with 1000 bits of precision. Or if I say B, but in the other ring, this is with 5 bits of precision. And if I say A plus B, what will happen? How many bits of precision A plus B will have?
Thousand bits?
So I can ask the parent of every element. So in Sage, every element has a parent. You see, the parent of the first one was this field. The parent of the second one is that field. Now I want to ask what is the parent of A plus B. And that will be, who said 1000? Or who can tell me why it is not 1000 in these 5 bits?
Because R1 is 1000?
Is what?
Because R1 is 1000.
Yeah, okay, but why the sum should be in the 1000 bit and not in the 5000 in the 5 bits? Mehmet. Hassan.
I don't know, sir.
Enis. I mean, ideas. Serna?
Hocam, the question is why parent is 5 bits. Is
Mhm.
that correct? Mm-hmm.
Yes, you said it should be 1,000, but it is 5. Why is
Yeah,
that?
actually, I was expecting 1,000.
Kanjan? Gizem?
I don't know, sir.
Taktan?
I think it's because there is no way of knowing the missing precision.
Exactly. So if I have, if this was not 5 and it was a SQRT of 2, I mean, the parent is still that. So the first one is this with 1,000 bits of precision, right? And the second one is this with 5 bits of precision. The same number, right? It's square root of 2, but one is with 1,000 and the other is with 5. Now, what happens if I take the sum? It's 2.9. Why? If I take the sum over 2, it's 1.4. Why I don't know. If I wanted the rest of the digits, what I would put? Why I erase? Sorry, I erased this. So what would be the next digit? 1 plus 0, right? Here I have zeros afterwards, no? So obviously, if I add and divide by 2, what I will get as a next digit is 0. Because 1 over 2 is 0.5. So I cannot get the next digit correctly because I don't have the digit here. So it's normal that the parent of that so say it decides correctly that the result of an operation has as much precision as the least precision of the operands. Because everything else, as Haktan said, you cannot know. You don't know the rest of the digits. Okay? Is that clear?
Yeah.
Yeah, it's clear, but I was thinking maybe it can calculate it, take the 0, the last digits of the B. But it's obviously it's working like that.
No, I mean, of course, the B, you can say that it's 1.40000 infinitely many
Yes,
zeros.
yes,
Right?
exactly. Yes, yes. I was expecting that actually.
But Sage knows that the reason why you have 0000 is just because the precision you have is 5 bits. So you only know 5 bits exactly. So if
okay,
you,
then
if you
it's
add a
clear.
number of whose you only know 5 bits, then you can only know 5 bits of the result, right?
Yes, yes. Then it's okay, hocam.
Okay. So now, for every structure we have, there is a great function, very useful, which is a random element. It gives you a random element from that structure. if you want to experiment, in general, this is extremely useful, right? As you probably understand. And as you see, a random element from Q is not necessarily not an integer. Obviously, well, 0 is not so random, but anyway. Q will always give us integers. That's interesting. Okay, so how do we want to make an experiment and we want to see how many times we will get something that is not an integer. So I will run it 100 times and I will make a list where I will have 1 if not in ZZ, else 0. And I will sum and see how many of those I have. And if I want to find the ratio, I will make this n, and I will divide this by n. And then I will have a sec int n. So this is about a third always. If I want to make this into a numerical value, I will say n for numerical, and now it will return the result of the division. And let's say again, so this was 33, 38. So it's always around 1/3 of what it finds is not an integer, but 2/3 of random rational numbers are integers. Okay, that's how you run a small experiment. So you really don't understand when you need the subtitles. So so who started closed captioning? Can you hear me? Who started closed captioning in the meeting?
Arkadaşlar hoca altyazı koymaya çalışıyor. Biriniz enable etmiş altyazıyı.
Okay. Did someone start this? Okay, I will start the meeting then. Join again, the same link. So, okay. Now, except for those rings and structures we have, there is a very useful one called SR, which stands for symbolic ring. So there are things in there that are not available in the other rings, but computation is much slower in the symbolic ring rather than in, for example, a polynomial ring. So we can define variables by giving names, right? So I say these are now variables, and I can say x square minus, I say cos, that's no. Well, apparently it knows, right? So this is a symbolic expression with symbols. And I can define then f, I say f2, 3, f3, 3. It doesn't know what this is, but I think that if I would say fxy, now it knows, right? Why didn't give me a number? Because this symbolic ring is exact, right? So in cos 3 would not be exact. But I can always say I want the numerical value, and I will get a numerical value. And I think I can say I want the numerical value with that many digits with whatever precision I decide. Okay? But if I don't ask for the numerical value, this thing is exact. Because exact value is this, right? So the symbolic ring is very useful. Let's see f dot parent. Now the parent of this is a callable function. So f is a callable function with these arguments. If I say just g is this, then the parent of g is the symbolic ring. Okay, so that's an expression belonging to the symbolic ring. But we discussed a lot about polynomial rings, right? So let's define a polynomial ring in the variables x, y, z. And how do we do this? We just say, I want a polynomial ring over QQ. You see now what R is exactly this ring. It's a multivariate polynomial ring because I have many variables. I have multivariate polynomial ring in x, y, z over the rational field. Another way to define this, by the way, if you use tab, it auto-completes the command. I want a polynomial ring over QQ with variables x, y, z. Right? It's exactly the same thing. Why is this version more useful? Oh, no, not more useful, but so you can say I want the list for I in range n. And let's say n is, let's not make it 1,000, let's make it 5. And now I have my polynomial ring in that many variables. So I can change this more easily. I can define my ring programmatically. But now can I say x0? It doesn't know what this is. It's not defined. Because these are the names I use internally in my ring, but outside the ring, we don't know what it is. How do we make this known? So what I can say is, for example, X is R dot gens. These are the generators. What is X now? It's a list of generators. And I can now say X0 is this. Okay? So we can use polynomial rings now, and we can define them programmatically. Questions? I will give exercises, so it's better if you ask questions now. So,
first of all, we define polynomial ring after n equal 10, and then what's that for x equal r point gens?
these are the generators. Gens is the generators. What are the generators of my polynomial ring? So what are the variables in my polynomial ring? These are x, y, x0 to xn, right? Since I have 10 variables, I ask for 10 variables, which are named x0 to xn. I mean, if I want to give...
Oh, we are keeping our generator function in x. Is that so?
Sorry, what generator?
We are putting our generator functions or generator terms in x.
They're not functions, they're variables.
Variables, okay. It's a container.
Yeah, or you can ask, also, you can say that a specific generator, if you want the fifth, for example, you can ask also like this. But if you ask for gens, it will give you a list of all the generators for the ring. Okay.
Hocam, are you gonna share this notebook later in Teams group or somewhere?
I can. Yeah.
Okay.
So
Thank you.
now then, okay, let me make this in 3 variables. And I actually like to name them from 0 to. I have now 3 variables, and I will even make it. You see, the instead of if I want to use directly x and y, the variables, I can use this notation. This defines, it's the same as saying gens. Okay, so now I did define x and y. So x knows, so Sage knows what is x, what is the parent of x. It is this ring, right? So if I say f is x squared minus x cubed minus scissors, then the parent is this. The parent of f is this polynomial ring. And just like with everything else, I have the ring and I can ask for a random element. Here's a random element from this ring. Okay. If you want to create, for example, polynomials with integer coefficients, you can just say and there you have 10 polynomials from there. In Sage, if you put a question mark, you get the doc string, so you get help. It returns a random polynomial of degree at most d and at most t terms. So this means that here I could make the degree 10 and the terms 3. And you see now I have a different, let's say at most 6, right? I can control what kind of polynomials I will get. Random, but with certain parameters. Okay? Questions? Okay, now can you all send me your CoCalc, how do you say, email so that I can, or username so that I can invite you to this project? I will create a new file, which is a course. Can you hear me? So
Yes, hocam. Just I think we need time to
I can
wait a
either
while.
I can either add you with your GTU where I send the email, or if you have a different email you use for Sage for CoCalc, you have to tell me. So I suggest we gather where in Teams. Can we have a document that everybody can how do you say, edit? I think so, right? No, I think it's not. So I cannot. Don't send it in here because I cannot copy etc. from the chat.
Okay.
So in Teams, I'm trying to create a file, but I cannot create a file in Teams.
Hocam, maybe you can download this file and upload Teams. Then we can also upload in CoCalc to open this file later to practice.
What file?
The file you made it in this class just now.
No, that's not. So if you go to Teams, there must be now a Excel file called usernames. Add your username there. They mail. I mean, by username, I mean they mail. Do all of you now have an account in? So you see the course in CoCalc?
Yes.
Okay. So if you all see, I will create an assignment now. And I will assign it to all of you. Assign to all. Now you should see a folder with the assignment. Can you open it?
It's still loading, hocam.
Okay. So it is assigned to all 14 of you. There are 21 people, 20 students here, but only 14 in CoCalc. Why is that?
I have just write my email to the Excel file.
I can't see the file where I need to add my email.
It is in Teams. It's an Excel file. People are keep coming. Okay. Now we are all here. Yeah, so people are also coming now to. Who started again closed captioning? Can you say who started closed captioning? I'm asking in order to know why you need this.
Arkadaşlar biriniz altyazıyı engelledi mi?
The course is
Orada
in English.
sorun.
We don't need everybody understands English. If someone does not understand English, then you shouldn't be in the class. But
Okay.
why is someone needs closed captioning? I mean, this is recorded, right? So why somebody needs to record the closed captioning? Okay. Again, we start again in 10 minutes then. Okay. So now you have all assigned an assignment in CoCalc in the course. Can you all see it? Is there anyone who cannot see the assignment? Can you hear me?
Yes, yes, sir. We can see.
Okay. So then, since okay, I will not add more people now. I mean, I can see that people are still coming. I mean, or I will add, but anyway. So let's discuss the assignment. If you open the folder of the assignment, the title is reduction, and you can find inside the file, right? Can you see the file? It says worksheet, and it has one comment saying create a function to do reduction. Is that correct? Okay. So now you should write a function that does polynomial reduction. So it will take two polynomials, two multivariate polynomials, and it will return. Sorry, it will take one polynomial and a set of polynomials, and it will return the result. Are there questions? Is the assignment clear? So we want a function that takes one polynomial and a set of polynomials, and it reduces the polynomial with respect to this set of polynomials. I'm here for questions, and I will collect in 15 minutes the exercise, okay?
Hocam, univariate polynomial we are going to use. Is that correct?
No, multivariate.
Multivariate polynomial. We are going to take two multivariate polynomial
No,
then.
we will take one polynomial and one set of polynomials. So there are no questions, right?
Teacher, I didn't see the assignment. I wrote my email address on Excel, but I can't reach it.
Okay, let's see. Do you see the course?
The assignment must under CoCalc project, right?
Under what?
CoCalc project in project section in CoCalc.
In the project, I think. Ask so your colleagues, what do they say? Where do you see it? In the course, right?
I don't know.
So why did you come so late? You were not here earlier?
I was at the beginning of the second class, 2:30. I tried to write my name in Excel. Then, if when you start, I already wrote my name. Then you said I didn't accept any email after this time. Then still I didn't reach. I didn't late, so that.
Okay, now you can see the assignment.
Thank you, sir.
Okay, for those who completed the first task, now you have the reduction function. Okay, is there anyone who completed that?
Hocam. Hocam.
I'm here, I can hear you.
Okay. I didn't complete the task because I don't know how to verify the generator function and the generator polynomial and term and the polynomial in Sage. I'm searching, but I couldn't find.
Can you
I
say
know.
again?
I know the reduction algorithm is in here in the text in front of me on the paper, but I don't know how to verify the generator term and
The generator term?
the polynomial is.
What is a generator term?
I mean the term in here. I just assign x0, x1, x2.
Okay.
And but for example, I create a random polynomial in here just on my screen, 4 times x1 x2 minus something x1 and plus a coefficient. I try to divide or check is it like the algorithm, but I couldn't make it. Let's say my polynomial is f.
Your polynomial is what?
Let's say my polynomial is f. I define like that, but I couldn't check to the f is x1. My x1 is dividing my my polynomial or etc.
Okay, anyway, in 3 minutes I will collect the exercises and we will see also the solution. Burak, did you put your name in the Excel? No, because you just arrived. So
Yes, sir, I did.
and then you are, can you see the course as a student?
I signed up, but not selected as a student.
Umit, can you see the course? Yes. Chala? Okay, I mean, now I will use this to grade, right? So I'm collecting the assignments. So if you don't see the project as students, I think now it's a good time to say it. If you are not in the course registered as students. Okay. So I will collect now the assignments. Is there someone who wants to present their solution? No one? Anyone? Okay, shall I choose at random? Okay. So here is the assignment. Can you see it?
Yes.
And that's the solution, right? So we want a function doing the reduction. It takes a polynomial as input and a set of polynomials. S is a set. R is the ring in which the polynomial belongs, the parent of f, right? Any questions until here? And then, okay, if f is 0, then we return 0, obviously. If and then we set the r, the quotient, sorry, the remainder to be 0. And while f is not 0, we choose one polynomial b from the set S. And if the leading monomial of b divides the leading monomial of f, then we did find such a polynomial, and we do the reduction as we saw last week. If we couldn't find such a polynomial, so if the flag is still false, then we remove the leading term of f and we add it to the remainder. And when f is empty, is 0, then we return r. Is it clear? So if I have a polynomial ring like this and I have two polynomials, then I want the reduction of f by g, and that would be the result. Anyone got it like this? Can you hear me? Okay, so did anyone submit this solution or something like this?
I submit something like this, but it doesn't work.
Okay, so now do you have questions about this solution?
No, it's clear for me.
So as I said, when you have an object in Sage, you can say dot and then tab to give you all the functions you can apply on this object. This way you could find the leading monomial, parent, leading term. So this LT is leading term, LM is leading monomial, right? Okay, so then let me assign the next one. Now you should see another assignment folder in the next few seconds, asking for the Grebner basis to implement Buchberger's algorithm. And we'll have another 15 minutes. But if you have questions, you should ask, right? So this is part of your evaluation, how you participate in the course. Also these assignments, right? Nobody has any questions yet? You have 5 minutes left. So from the assignment I collected, most of you didn't write anything, right? So you should try to solve the problem. If you don't know how to start, you have to ask. I will collect in 3 minutes then. I'm very surprised there were no questions. Also, I returned the previous assignment graded. Can you see what I returned? And comments in the notes?
Yes.
Okay, I'm collecting the second assignment. Anyone who wants to show the solution? Nobody? Okay.
Sir, I cannot see my first assignment grade, and also assignment just disappeared. Is it normal?
The second assignment or the first assignment?
The first assignment.
It's normal that the first disappeared because I collected it, right?
Okay.
Also, the second one should also disappear now. But can you share your screen? Can we see the?
Yeah, it just appeared right now. Probably the latency, internet latency, due to internet latency. Thank you.
Okay, so this was the second assignment, right? So we will need, of course, the reduction. That's one thing we need for sure in order to do Buchberger, right? So this is from the previous assignment. And then we will need the S polynomial. If we take the S polynomial of f and g, where f and g are polynomials, again, we have to know who is the parent of f. We call it R. And then we need the least common multiple, the LCM, of the leading term of f and the leading term of g, right? And then what we do is we divide the LCM by the leading monomial and multiply by f. We do the same for g, least common multiple divided by leading monomial times g, and then we subtract the two, right? Now the problem is that if we divide a monomial with a monomial, officially, I mean, this is not a polynomial anymore, right? This is a rational function. We cannot divide in a ring, but we know that the leading monomial of f divides exactly L, which is a least common multiple. It's a multiple of FLM, right? Since we know it's a polynomial, we can embed it again in the ring. We can cast. So we say, I want the result of this division in my ring again, in my ring R. And I do the same here. So now this S polynomial is in the same ring that F was. It's in the same parent. Do we agree? Did anyone write a function for S polynomials? No one? Okay. So, and then the Buchberger algorithm is we get a set G, and then we compute the S polynomials for all the pairs. So for I in the range of length of G, as many polynomials we have, and for J in the range from 0 to I. This is how we take all the pairs, but not ij being the same. And we compute the S polynomial. And now we have a list of all the S polynomials of these pairs. And you remember the algorithm says that as long as this list, when this long is empty, we are done. If this list is not empty, then we take one S polynomial from there and we reduce it by our set G. If the remainder, the result of the reduction, is not at zero, then we have to put this R in G. This is what we do here. But before we do that, we have to add all the pairs of S polynomials of this polynomial R with every G in our list of polynomials G. We take all the pairs again, right? And since we did reduce the first one, we remove it from the list of S. And when this is done, we return G. Now this is the Grabner basis. Questions? And let's try it. So for these two polynomials, you see the Gremner basis now contains 3 polynomials. We had to add a polynomial, and this is our Gremner basis. Questions? Okay, now I will give a homework about real root isolation, isolating the roots, the real roots, using Sturm sequences.
Hocam, could you please scroll down this slide? Okay, thank you.
Which part of this code you found confusing? One thing is that when you write a function which takes a polynomial, you don't know what this polynomial, how many variables it has, or whatever, right? So if I have my polynomial, so I have a polynomial ring, and I want to know what is the this is a very easy function, right? G of f, where f, let's give a name to this polynomial ring. I want a random element. So it returns the random element. But here, let's say I want to do something, and what I really want to know in here is what variables do I have, for example, right? How can I know this? Well, this is very easy. I am asking what is the parent. That's essentially one of the first things you will have to do always. So here, the polynomial changes. But the ring doesn't. See? And this is how I know what is my ring. If you want to write a function that works for every multivariate polynomial, then essentially you have to use this parent function so that you know what is the parent, since the user essentially decides what are the polynomials. You cannot decide who is the parent, how many variables your polynomial have. The user will do that. Do we all follow? Okay. Now, if I have a univariate polynomial, this is less important, of course, but still, you may want to do this. Now, let's say I want let's say I have actually a univariate polynomial. Okay. And what I want is the coefficients of f. How am I going to do this? I don't know. Let's call f this random element. Okay. How am I going to get the coefficients of f? Suggestions? Chala? Ismail?
Blood coefficients.
So even if I didn't know, I would just do f dot. I want to do something with this. I will get all the stuff I can do with a polynomial. But I know I want something related to coefficients. So let's say, okay, apparently there is a coefficients function, and I will check what it does. It returns the coefficients. How is it possible that I get twice? Why I get a random element to be 0? Yeah, okay. So you see these are the coefficients: 1/3, -1, -2/7. So I get the coefficients. What if I said here 100? Is this the degree? Yeah. You see, I also get the coefficients. Now, one problem I may have is that, am I going to create that? Okay, I will create my polynomial to be, I need my variable now by name, is a sum let's say I want degree 100. I will create a x to the 100, x to the I times some coefficient. Let's say zz dot random element times this. Okay, let's make it 10 so that we can see it. You see, I chose random coefficients for every monomial, and then I add them up. Okay. If I do it for 100, then I have this. And let's say now I want to do, I want to have it sparse. So this is that if I is greater than 2, sorry, smaller than 3, how do you say or? Is it like this in Python? I greater than 90, then d minus 2. Is it wrong Python
Lowercase.
here? Sorry?
Lowercase. It must be lowercase or.
Else 0. Okay. What? So are we here? So you see here, I take only terms that are whose degree is smaller than 4, like 0, 1, 2, 3, degree up to 3. There's no x to the 4. And only things that have degree greater than d minus 4. Okay? D is 100, so I take everything of degree greater than, why is it not 96 there? 97? Any idea? Okay, that was random. It was just 0, the random element. Okay? Now the problem is, if I take this coefficient list, I don't know to which degree this corresponds. So in order to get the full list, I will say that this is, I don't want to see it as sparse. Give me also the zeros. Okay? On the other hand, if you really just want to see the sign changes, for example, this is enough. Do we agree? Are we following? Is there someone who wants to share now and do the real root isolation algorithm? Sena,
Sorry, I couldn't do it.
Haktan, at least give ideas on what you will do in order to solve this. So what I need is a function. I'm giving a polynomial f, and I want to isolate the real roots, right? Return I, where I is a list of isolating intervals. What do we need to do inside? So remember, the first thing, so what we need to do is subdivision. Let's define a subdivision function that takes what? A polynomial and an interval. Are we fine till there? by default, this interval should be empty. Now we say that if I is empty,
Hocam, we cannot see the screen because it's very, oh yeah, no.
like this,
More up, please.
here.
Oh, yes.
So if it is empty, then let's make it to be something. This means it's the first subdivision step. Then we need something like minus. Remember, we need an interval that contains everything. So minus some absolute bound of f to absolute bound of f, right? But then we need to define such a function that gives us the absolute bound of f. Who remembers what this is? So let's take the Cauchy bound. The Cauchy bound was the largest coefficient divided by the leading coefficient, right? So let's say that L is the list of coefficients of f. I want it sparse because I want to know which one is the first, the leading. So the leading is the last coefficient, which means this -1 in Python gives you the last element of a list, right? So I will take every element in the list, divide it by the leading coefficient, and take the absolute value. And among them, I will take the maximum. That's the Cauchy bound. So now I do have a bound. When I say isolate, I will need some subdivision. But okay, for the moment, let's remove this and say subdivision of f of f. That's what I want. Let's define the polynomial ring so that I can give the polynomial. This is a univariate, right? Because it's a real root isolation for univariate polynomials. My coefficients are from Q, and I have the polynomial. Let me take one that I know the roots. I will say x minus 1 over 2 times x minus 1 and x plus 2. So this polynomial has roots 1/2, 1, and -2, right? Let's see where we are with I. This is the absolute bound was -5 over 2, so that's wrong. Why is it wrong? Because I need the +1 there. Now it's okay. Because otherwise -2 was not in the interval, but now -2 is in the interval. Okay. So I have my interval if I'm at the first step. And what I do is I need to find the middle point, right? What is the middle point in order to subdivide? Well, it is the first element of the interval plus the second element of the interval divided by 2. That's a rational number, that's fine. And now I say my left interval is from there to M. And I split it in 2 intervals, right? And the right one is from M to the right end of the original interval. Okay, I had an I, now I split it in two. Questions until here? Now, the next step in subdivision was that I have to count how many roots I have in this interval and act accordingly. So if I have 0 roots, I will just forget about it. If I have 1 root, I will put it in the output. And I have more than 1 root, I will subdivide. So what I need is if root count of f in I is greater than 1, I do something. What I do, I subdivision else elif root count is exactly equal to 1. I return this. But I need to do this for left and right, right? So I cannot directly return here because yes, I need to subdivide, but then I will collect isolating intervals from that I get from here. So if I have exactly 1 root, I will put in this list L or R, my left or my right interval. And in general, I will return this. Okay. Now, if I subdivide, I have to subdivide left for the same polynomial, right? Or right. And now, what does subdivision return? This is a recursive function, right? It returns a list of isolating intervals when I call this function. So what I want here is II extend with whatever this returns. Do we agree? Any objections? No objections? Okay, then let's stop here. The assignment you'll have is to finish this real root isolation using Sturm sequences, for example. Okay? Questions? The reason why we had today these assignments is because I want to write code, and I want to see how you write code, and then we'll discuss the code. So we will do a couple of these sessions in order to see how to write code for, well, I mean in general actually, but also for symbolic computation. You're given a problem, how you solve that problem, right? By coding. So, and we will probably use CoCalc, except if it becomes problematic because it's slow, etc. Don't pay anything to CoCalc. I mean, of course, if you want to pay, it's fine to support an open source project, but you don't have to pay for the course, okay? Questions? Okay. Then see you next week. You too.
See you.